Hello gems, welcome back to another video. First and foremost, a very happy new year, and like a wise man has always said, true relevance never really dies. So A series is back. Those who have no clue about it, A series is basically a series wherein we discuss the previous year questions of Bitsat. Okay, the discussion is chapter wise. We pick one chapter and we discuss all the previous year questions from that particular chapter. Okay, so I think this will help you a lot in your preparation. Actually, this series is something which we started for Bitsat 2021, and unfortunately we couldn't complete certain chapters. Okay, so we'll be completing those chapters in January 2022. So if you haven't subscribed already, hit that subscribe button so that you don't miss out on those. Also, if you want to check out the previous videos of A series, I'll put them in the description box of this video. You can check out the playlist over there. We have discussed a pile of chapters. Only few are remaining, and we'll do it now in 2022. Okay, and the chapter that we are going to discuss today is rotational motion. So without further ado, let's get started. So let's begin with the super easy category like we always do for A series. So here is a question from 2011. Okay, it has given you the torque of a system. You are also given the angular acceleration of that system in SI units. You are supposed to determine what is the moment of inertia of that system. Okay, very straightforward question. You are just supposed to use the relation torque equals I alpha, right? Just like force is mass into acceleration, torque is moment of inertia times angular acceleration, right? So from here you can easily find moment of inertia. It will be torque by angular acceleration. So torque is 31.4 divided by angular acceleration 4 times of pi. Pi you can approximate it as 3.14, and this will get cancelled beautifully. 10 by 4 or 5 by 2 or 2.5. Okay, so 2.5 in SI units, option A is the correct choice over here. So at least 2 to 3 questions will be formula based in the Bitsat paper that you are going to answer. Okay, so formula based questions are the trends that we see in Bitsat papers, right? At least 2 to 3 questions. Okay, so study your formulas properly. Anyways, let's come to question number 2 now. Here you are given an object which is rolling with uniform velocity. Okay, you are also shown two particles on that object. Okay, it's a circular object and you have 2 points marked. Okay, those 2 points are diametrically opposite, A and B. You are supposed to tell what is the acceleration of particle A with respect to particle B. Okay, now for those who don't know about this, it has a simple formula. The relative acceleration AB is given as acceleration of A minus acceleration of B. You might have heard the concept of relative velocity, right? VAB is VA minus VB, right? So simply, so this you can write it this way. Okay, AA minus AB. Okay, so it's a very simple thing. Now you are just supposed to find what is the acceleration of A and acceleration of B. And how will you find that? If you see, they have already told you that it is rolling with uniform velocity, right? So if you see, the particles on this object will be performing uniform circular motion, right? So since the particles are performing uniform circular motion, the only force on that particle is the centripetal force, right? The motion is uniform. There is no tangential acceleration, for those who know it, or for those who don't know, the only force acting on the particles of this object is the centripetal force, right? So we can write the only acceleration on each of these particles will be the centripetal acceleration, right? It will be different based on the where the point is. Okay, so acceleration will be given as v square by r. This is the formula for centripetal acceleration, right? So acceleration of A is v square by r. It will be towards the center, right? Centripetal acceleration is towards the center. So here we have v square by r, where r is the radius, distance from the center, right? So here if you see point B, it's also on the outer edge. So if you see, it will be also v square by the distance from the center, which is the radius. Okay, so v square by r. Okay, so if you see, both are v square by r but in opposite direction, right? Towards the center, So you can take the downward direction as positive, so you can write v square by r. So this will be acceleration of A is v square by r, right? It's plus v square by r, and acceleration of B is in the upward direction, opposite to the downward direction. So that should have a negative sign, v square by r. It's same in magnitude, different in signs, right? They are in the opposite direction. So yeah. So if you solve this, it's basically 2v square by r. As simple as that. Okay. So here you are just supposed to find or know that the only acceleration in this case, since it's uniform velocity, the only acceleration will be the centripetal one, which is v square by r, and then just substitute a acceleration of point A and point B, get the answer, right? So that was so simple. Let's move to the next question now. So question number 3 and 4 over here from 2007 and 2008. Okay, so these are a bit conceptual type of questions. So I want you to keep them at the back of your head. Okay, very, very good questions actually. Okay, so here we have an inclined plane. On that inclined plane, we are going to roll down a disk and a sphere. Now both the disk and the sphere have the same mass m and the same radius r. Okay. Now when we roll them down the incline, we note that we come to a conclusion when we make the observation. We see that they reach the bottom of the incline at different times. Okay, one outspeeds the other. Now some of you might be puzzled, how does this happen when the acceleration for both of them is the same acceleration due to gravity? Well, that is not the case. Okay, the acceleration for rolling has a different formula. Okay, the acceleration in this case will be given as g sine theta upon 1 plus k square by r square, or I square by mr square. Okay, so here you can see that here they have given you that they will reach at different time, because if you see, you are supposed to reason why will they reach at different time. Okay, so here from this formula you can easily make out that their acceleration will be different, right? Because the acceleration depends on the radius of gyration, which is different for a disk and which is different for a sphere. Basically, radius of gyration is the moment of inertia of whatever body it is equals mk square. From here you'll get the radius of gyration. For suppose what is that? Disk. Okay, disk is mr square by 2, right? This is the moment of inertia of disk. Okay, you'll put this equal to mk square, m and m will get cancelled. From here you can find that k is under root of, or you can write r by root 2, right? And similarly, if you do it for sphere, okay, which has moment of inertia of 2 by 5 mr square, the k value will be different. So the k value is different for both of them, and hence the acceleration will be different. Since the acceleration is different, they will be accelerated at different rate, and one will reach before other. Okay, one will outspeed other, or they will reach at different times. Okay, so the correct answer over here is, why do they reach at different time? Because they have different radius of gyration. Option D is the correct choice over here. Okay, now if you have understood this question, this one is very, very simple. You can give it a humble try. In fact, okay, I'll read it for you. Two unequal spheres. Okay, this two spheres differ in terms of mass and radius. Okay, one is big, other is small. One is heavy, other is maybe light. Okay, so they differ in mass and radius, unequal basically. Okay, are released from rest. Okay, same scenario, from rest from the same height on a rough inclined plane. Okay, you are supposed to tell which one will reach first. Does the heavier one reach first? Does the bigger one reach first? Is the data insufficient? Okay, or both reach together? You can pause the video here. You can give it a humble try. Okay, I'm going to spill the answer in 3, 2, 1. The correct answer over here is option D. Okay, both will reach together because they have the same radius of gyration, not moment of inertia, sorry. They will have the same radius of gyration, because basically these two are solid spheres, right? For sphere, the moment of inertia is 2 by 5 mr square. Okay, if you put this equal to mk square, right? So k will be given as 2 by 5 under root 2 by 5 r, right? I hope I didn't make any mistake. Yeah, so this k value is same for both, right? Basically the r will get cancelled with this one. So r square, when you square this, okay, the r square and r square will get cancelled. So it does not depend on mass or the radius. Okay, so it only depends on the radius of gyration, basically this factor of radius of gyration. Okay, so both will reach together because they have the same radius of gyration, or both have the same this factor of radius of gyration. Okay, so I hope you were able to understand this. Rewind and watch it again if you were not able to. Let's move to the last question from the super easy category. So question number 5 over here, the last question from the super easy category, and then we'll move to the easy category. Okay, now in this question you have two identical spheres which are same with respect to mass and radius. They are smooth in nature. Okay, the sphere A is moving with translational velocity v and some angular velocity omega. Sphere B is at rest. Now after some time they will undergo elastic collision. I hope you know what that is. Even if you don't know, it's okay for this question. Okay, so after some time they undergo collision, and after collision omega A is the angular velocity of A and omega B is the angular velocity of sphere B. Okay, you are supposed to tell which comment about omega A and omega B is correct. Okay, you can in fact give it a try. It's very simple actually. You just have to catch one thing over here. Okay, so the thing to catch over here is they are smooth. Okay, since they are smooth, one particular sphere cannot exert some rotational torque on the other. Okay, whenever they collide, one sphere will be rolling like this, right? This will be rolling against it, but they are smooth, so it cannot induce any torque. Okay, so basically sphere A will not be able to induce any torque or any rotational motion on sphere B. Okay, they will just exchange their, since it's elastic collision, they are identical, they will exchange their translational velocity. But since they are smooth, uh, sphere A cannot induce some rotational motion in sphere B. Okay, and in that case the sphere A will continue with the same angular velocity. Okay, the angular velocity of sphere A will not change, although the translational velocity will be exchanged, right? So omega A will be same as omega. Where is that? Omega A will be same as omega. Okay, I hope that is clear. You are just supposed to uh, pin this over here. Okay, they are smooth. One cannot induce rotation on other. Okay, so omega A should remain same as omega. Okay, now let's move to the easy category. So question number 6 and 7 over here from the easy category now. So again you have an inclined plane. Now this inclined plane, rolling on inclined plane is very favorite topic of Bitsat. We can say that, right? It's a high weightage topic. As you can see, it's repeating over and over again. So focus on it. Okay. So let's come to the question. Here you have an inclined plane. On that you are rolling a solid sphere now. Okay. You are supposed to deduce this ratio. What is the acceleration of rolling of this sphere to the sliding? Okay, one time you are going to let it roll and the second time you are going to make it slide. Okay, sliding, and the second thing is rolling. Okay, you are supposed to tell the ratio in that case. Okay, first of all we know the formula for rolling, right? I just mentioned it in the previous question, so from there we can find this term, and for this term it's actually very simple. This is something that you learn from Newton's law. Okay, the acceleration along the incline for sliding object, for objects in translation motion, is basically given as g sine theta. Okay, this is a result which I tell you to by heart in the laws of motion, right? So along the incline it is g sine theta, and perpendicular to the incline it's g cos theta, which goes to balance the normal force. Okay, so basically g sine theta is the component which is responsible for sliding. Okay, so g sine theta is the acceleration when the object is purely sliding. And what about rotation? You already know it. So for that we have g sine theta upon, it also depends upon the k factor, right? So k square by r square, or I can write it as in a better way, I by mr square. Okay, for those who don't know about radius of gyration, right? So you can use this formula. From here you can write that it is g sine theta upon 1 plus the moment of inertia of a solid sphere. You should know this by heart, that it is 2 by 5 mr square. Okay, so 2 by 5, 2 mr square by 5, and in the denominator you have this mr square, right? So mr square will get cancelled, and you have g sine theta upon 1 plus 2 by 5, or I can write it as 7 by 5. right? 7 by 5, again that will go on top, so 5g. Basically the answer of this is 5g sine theta by 7. Okay, now you are asked for the ratio of this to this. If you take the ratio, you can easily see that g sine theta and g sine theta will get cancelled, and yeah, it will be 5 by 7, right? So option A, 5 by 7 is the correct choice over here, right? You are just supposed to know this formula, and you are just supposed to know this fact, right? Remember this, for a sliding object down the incline, the acceleration basically is the sine component of the weight. Okay, mg sine theta, the force is mg sine theta, acceleration is g sine theta along the incline, perpendicular to the incline, g cos theta. Anyways, let's come to question number 2. Okay, here you are supposed to find the ratio of the kinetic energy, rotational kinetic energy, to the total kinetic energy. Here you are rolling down a ring, okay, down the incline. Okay, this rolling is pure rolling. Okay, so for kinetic energy in rotational motion, I can write it as half I omega square, right? So half mv square just replaced by half I omega square, right? Angular, basically angular inertia, you can say, moment of inertia, and omega is the angular velocity, right? So here omega can be written as, if you, this condition is for pure rolling, so we are told in the question that it is pure rolling. Okay, so v equals r omega, and omega can be written as v by r, right? So here you'll get half I, actually you can write I for the ring as well. Ring, for ring it is mr square, right? I for ring is mr square. Remember this for all the bodies, the continuous bodies. Okay, and omega is given as v square. Omega square will be v square by r square. R square will get cancelled. Rotational kinetic energy is half m v square. Okay, interesting. Okay, and if you see for the total kinetic energy, the total kinetic energy basically is the rotational kinetic energy plus the translational kinetic energy, right? This ring will have also have, suppose it has some velocity v. Okay, it does has some translational velocity v, right? So now rotational kinetic energy, you already know it as half mv square plus the total kinetic energy, sorry, the translational kinetic energy, which is half mv square. So this will give you mv square, right? So basically you can see that the kinetic energy, total kinetic energy, is 2 times the rotational kinetic energy. So this ratio will be half, right? You can take this ratio, it will be half. This by this, mv square cancel, 1:2 is the correct choice over here. Okay, so very simple question focused on the topic of rolling down an inclined plane. Okay, so please focus on this topic. It is a very high weightage topic in Bitsat. Let's move to the next question now. Question 8 and 9 over here. So let's get straight to it. So question 8 from 2008. In this question, you have a disk of mass m, radius r, moving with an angular velocity omega as shown. Okay. Now you are going to put one more disk of mass, same mass m, but radius half. Okay. You can see this disk. Okay, without disturbing the original thing. Okay, or without applying any external torque. Okay, this is done in a very smooth manner. Okay. Now you have a system. You are supposed to tell what will be the omega of this system. Okay, now you know where this is going, right? There is no external torque. So what is it? It is angular conservation of angular momentum. Okay, you know, but I don't know. Okay, anyways, so the basically you have to use the formula I1 omega 1 equals I2 omega 2. Conservation of angular momentum is more subtle than this, but anyways, this will do for now. Okay, so I1 omega 1 equals I2 omega 2. This is conservation of angular momentum. And I1, if you see here, this is the case 1, this is the case 2. Okay, so case 1, what is the moment of inertia? You can simply say it is mr square by 2. For disk, it is mr square by 2, right? Now, omega 1 is omega, right? I2, you are supposed to find the moment of inertia of this system now. So basically, if you see, it's just mr square. Moment of inertia is a scalar, right? It's a tensor, but now considering it a scalar would do. Okay, so mr square plus the moment of inertia of this. Okay, so basically it does not have any direction as of now. Okay, so you can just add their magnitude, right? So moment of inertia due to this disk plus moment of inertia due to this one. This one is m r square by 2, but r the value is r by 2 whole square by 2. Okay, so m r square, the radius is different, it's r by 2 now, divided by 2. Okay, when you add this, it will be m r square by 2 plus m r square by 2 into 1/4, right? So this is like mr square x plus x by 1/4. So 1 plus 1 by 1/4, what is that? What is 1 plus 1/4? That is 5 by 4, right? So 5 by 4 mr square, right? 5 by 4 mr square by 2. Okay, you can just add it. This is the answer that you'll get. So this will give you the, here omega 2 will be the omega of the system, right? So you are supposed to find omega of the system in terms of omega. So mr square by 2, this thing gets cancelled, okay, and it will be 4 omega by 5. Okay, 4 omega 5. Option B is the correct choice over here. Let me just check that. Where is that? Yes, it's the correct answer. Okay, so option B, 4 omega by 5 is the correct choice over here. Okay, simple conservation of momentum. So now coming to question 9, here you have three masses, discrete masses m, m, m. You are also given their coordinates 1, 1, 2, 2, 3, 3. Okay, x and y coordinates. You are supposed to tell what are the coordinates of the center of mass. Okay, so coordinates of center of mass. Okay, now you have a formula for this, but the formula is for dummies. Okay, if you see, you can directly see the symmetry over here, right? In this question, you can directly see the symmetry. All the three masses are m, m, m. They are equal. And if you see that this distance equal this distance, so this is the midpoint of the system, right? So basically, the coordinates of center of mass will be 2, 2, right? Or let's do for the dummies. Okay, sorry for calling you dummies. Don't unsubscribe to this. I don't mean it. I'm just kidding. Okay, so we all are dummies. Okay, so x cm, the x coordinate of the center of mass, it will be given as m1 x1 plus m2 x2 plus m3 x3 upon the sum of the mass, which is m1 plus m2 plus m3. Okay, so that is the formula. We'll just use it. M1 is m, x coordinate is 1, m2 is m, x coordinate is 2, m3 is also m, x coordinate is 3. Okay, now that will be m plus m plus m, right? So that is 3m. M can be cancelled out throughout, so this will give you what is that? 2 plus 3, 5, 5 plus 1, 6, 6 by 3, that is 2. Okay, so the x coordinate is 2, y coordinate in a similar way, you can see all the masses are same, and if you see y coordinate is also same, so that will also give you 2. So 2, 2, or you can just go by the symmetry. 2, 2 is the correct choice over here. Okay, so let's move to the next question now. So question number 10, here you are given a rod of length L, mass M. You are also given the moment of inertia about this axis. This axis is going inside. Okay, so it is somewhat like this. Okay, this rod can rotate in this direction, in vertical plane. Okay, so here you are supposed to tell what is the angular acceleration. Okay, and you are given the moment of inertia. Actually, you are supposed to know it. That moment of inertia of a rod about this axis is ml square by 3. Anyways, it's given in the question. It's from 2017. So let's try it. Okay, so how will you do this? Actually, it's very simple. You'll just use the equation that we used in the first question, which is torque equals I alpha. Okay, and here if you see, the torque will be due to its weight, right? It is rotating in this plane because of its own weight, right? And weight is acting at the center of mass, okay, over here, okay, at a distance L by 2. Okay, so here we have the weight mg. Okay, so torque, we can write it as F into R. Okay, F and R, if you see, both of them are perpendicular, so sine of 91. So torque, you can basically write F into R, and that will be I times alpha, right? So F is for real, Fr. Okay, so F is, if you see, mg, and the distance r from the axis is L by 2. Okay, keep in mind that the mass is concentrated at the center of mass. This is a uniform rod, we are assuming that. Okay, and I will be given as, it's already given, ml square by 3. Okay, alpha you are supposed to find. Now just cancel out things, m cancels with m. The answer will be 3l, one of the l will get cancelled, 3g by 2l. Okay, yeah, these two options are dimensionally inconsistent. Okay, the only correct option over here should be option C. Okay, 3g by 2l, this is dimensionally consistent, but yeah, this is the answer that we get. Okay, 3g by 2l is the correct choice over here. Okay, so simple use of torque equals I alpha, and torque is due to its own weight, right? So that is the only logic in this question. Let's move to the next question. So question 11 and 12 over here, we are still there in the easy category. Okay, so if you see, question 11 was repeated in 2007 and 2013. Okay, in this question we have two rings. Okay, the smaller one for your better half, the bigger one for mine. Okay, so she's fed basically. Why am I so aged today? Anyways, so the ratio of the moment of inertia, I1 and I2, I1 for this ring and I2 for this ring, is given as 1 by 8. Okay, this ratio of their moment of inertia is 1 by 8, 1 is to 8. It is given that they are made of the same material, so find this n so that it fits her. Okay, so basically find the value of that n. Okay, what is this n times the radius? Okay, how big is that n? Okay, so first of all, we can use this data, right? I1 we can easily write it as mr square, right? Mass of this ring times the radius square, right? But here's the problem, we don't know anything about their masses, right? So since they are made of the same material, we can assume that they will have the same linear mass density, mass per unit length, right? So length, if you see, is basically the circumference, right? For a ring, the length is the circumference. So I can write it as 2 pi r for this ring. Okay, so mass of this ring 1 will be basically lambda times 2 pi r, right? So mass over here is lambda times 2 pi r. Lambda is constant for both of them because they are same material, right? So r over here, lambda 2 pi r, right? And r square, that will make this r cube. So similarly, we can find I2. I2 will be given as mass of this ring times the radius of that ring squared. Okay. So first of all, we can write lambda for this ring as mass of that ring divided by the length, right? Length is basically the circumference. So 2 pi n times r, right? The radius over here is nr. So you can write m2, the mass of this second ring, as 2 pi, okay, lambda times 2 pi nr. 2 pi nr, right? So here the mass formula is basically the same, mr square for a ring. So mass is lambda 2 pi nr, okay, and the radius is nr, right? So nr square. Okay, so basically you get lambda 2 pi n, this will be n square and n cube, and here you'll get r cube. If you see, if you take the ratio of this two, right, that is what we are supposed to do, I1 by I2, that will give you, if you see, lambda 2 pi r cube, lambda 2 pi r cube will get cancelled and you'll be left with 1 by n cube, right? This will remain lambda 2 pi r cube, lambda 2 pi r cube. So 1 by n cube, so basically n cube is 8. Okay, solving this, or you can write simply 1 by 8 is 1 by n cube. Okay, so n cube is, you can write 8 as 2 to the power 3, or basically comparing, you can see that n value should be 2. Okay, so 2 is the correct choice over here. Okay, that n value is 2. Okay, so simple use of this logic. Okay, we found the moment of inertia of this, moment of inertia of this. Since they are made of the same material, they will have the same linear mass density, mass by length. Okay, so lambda is same for both of them. Okay, from that we wrote m in terms of lambda. Okay, and then we took the ratio, and that gave us our answer. Okay, now let's come to one similar type of such problem. Okay, here we have a disk of mass m, radius r. The moment of inertia of this disk is given as I. Okay, that I will, if you know, it's mr square by 2. About this axis, it is mr square by 2, right? Now you melt this disk, okay, and made a solid sphere out of it. Okay, this is a solid sphere. The radius may or may not be the same. Okay, so basically whatever volume of disk was there, you melted it and made a sphere out of it. Okay, you are supposed to tell what is the moment of inertia of that sphere about a diameter. Okay, just find the moment of inertia of that sphere about a diameter in terms of moment of inertia of this disk. Okay, so we already know for disk it is mr square by 2. Okay, so one thing we can see over here is that volume is conserved, right? Whatever volume of disk was there, you just melted it and recasted it into sphere, right? There is no loss of volume. So volume of this disk. Okay, now what was the thickness of this disk? I forgot. Okay, the thickness of this disk was given as r by 6. Okay, so that is the thickness. Okay, so basically I'm saying volume of disk will be the same as volume of sphere. Okay, because you use the same material, you melted all of this and made a sphere. Okay, there was no loss of the volume. Okay, so volume of this equals volume of sphere. This is a cylinder, so we can write it as pi r square. So pi r square, radius square, which is r, into h. H is the thickness, which is r by 6. Okay, it was given in the question. And now for solid sphere, you can write it as 4 upon 3 pi r cube, right? That is the formula for volume. So r will consider it as small r, the radius of the solid sphere as r. Okay, that is the thing we are supposed to find. Okay, that will help us tell the moment of inertia of that sphere. Okay, r cube. Okay, 4 upon 3 pi r cube. Okay, now pi and pi will get cancelled. R cube. Okay, here you get r cube by 6, 3, therefore 3 2 4 2 is 8. Here you'll have r cube. So basically solving this, you'll get the radius as r by, this is 8, so any cube root, that is 2. Okay, so basically the radius of that sphere is half of the radius of that disk. Okay, so basically we conserved volume and we got that the radius of this sphere is half of the radius of the disk. Okay, now you can easily find the moment of inertia of that solid sphere. For solid sphere, the formula is 2 by 5 m, basically the mass of that sphere. Now the mass will remain the same, right? There was no loss of mass. Okay, and r square, right? 2 by 5 mr square is the formula for solid sphere, right? So just substitute this value over here, so you'll get 2 by 5 m r square by 4, right? Now get it in terms of the moment of inertia of the disk. Okay, we can write this as, I can cancel this, you'll get 1 by 5 times mr square by 2, right? 1 by 5 times mr square by 2, which is nothing but the moment of inertia of the disk. So the answer over here should be I by 5. Okay, I by 5. Yeah, that is the correct answer to this question. So basically, conserve the volume, find the radius of the sphere. The radius will help us finding the moment of inertia of the sphere. Okay, and finally just do some arrangement so that you can compare the moment of inertia of the sphere with the moment of inertia of the disk. That is what we did. Okay, let's move to the next question now. So question number 13 over here. Now this question is from the easy to moderate category. So we have stepped up the level now. So here in this question, you are, the question is a composition of projectile motion and your angular momentum. Okay, so basically you are supposed to find the angular momentum of this projectile when it reaches its maximum height. Okay, angular momentum about origin when this projectile reaches its maximum height. Okay, now angular momentum will be simply given as the linear momentum times the perpendicular distance, we can say that, right? When this projectile reaches the maximum height, the only component of velocity acting will be the horizontal component, right? The vertical component will slowly goes on decreasing and finally becomes 0 when the height achieved is maximum. That's why it does not move up, and that is the maximum height, okay, by definition. Okay, so the only component when the object achieves its maximum height is the horizontal component. Okay, and in that case the horizontal component in this case over here will be v cos theta, right? So v, so initial velocity was given as v, so v cos 30, right? So adjacent to theta is cos theta, opposite to theta is sin theta. Okay, so v cos 30, or which is root 3 by 2. Okay, so this is the component of velocity we have. If you see, the linear momentum is basically given as m into v, and you have to consider the perpendicular distance over here, right? So m, v we already know. Now we can substitute that. Okay, v in the you can say this v, what can I call it? I can call it v dash. Okay, so we'll substitute v dash. And what about the perpendicular distance? It is nothing but, if you consider the origin as the point of projection, so from this axis you can see the distance, the perpendicular distance is nothing but the maximum height. And how is maximum height given? You know the formula, it is v square sine square theta by 2g. Okay, please remember the formulas. Formulas are very important for Bitsat, right? So this is the formula for projectile motion for maximum height. Okay, so v square sine square theta by 2g. V is the velocity of projection. Okay, so here you can see that theta is 30, right? The angle of projection is 30, sine 30 half. So v square by this will become 1/4, right? Half square, that is 1/4. So v square by 8g. Again we have 2, so v square by 8g, that is the maximum height achieved, or that is the perpendicular distance. Now just substitute over here and you'll have your answer, right? So m, velocity is v root 3 by 2 into the perpendicular distance is v square by 8g. Okay, so you can see it will be mv cube, okay, m root 3 mv cube upon 16g. And which option is that? Option D, right? So root 3 mv cube by 16g is the correct choice over here. Okay, so direct application of the formula of angular momentum, and then you just have to look out for the perpendicular distance. Okay, and some concepts of projectile motion are necessary over here, right? This formula, again, the only component is the horizontal component, those ideas, okay, of projectile motion. Okay, so that was a question from easy to moderate category. Let's move to the next question from the same category. So question 14 over here, again from the easy to moderate category, and in this question you have a wire of length L. Okay, its mass is m. The linear mass density is given as rho. Okay, now this wire is bent into a ring. You are supposed to find the moment of inertia about this axis x dash. Okay, it's along the tangent if you see. Okay, now how will you do this? It's actually very simple. First of all, we can find the radius of this ring, right? Because we'll need that in the discussion of moment of inertia. Will require r square, right? So how will we find the radius? Basically, you can see that this ring was made from this wire, right? So the length of the wire equals the circumference of the ring, right? So L equals 2 pi r, or your radius basically equals L by 2 pi. Okay, so we found the radius, one job done. Now what is our next job? We want to find the moment of inertia, right, about this axis. So we can use our parallel axis theorem. First of all, you can find the moment of inertia about this axis, which is passing through the center of mass, right? And then what does the parallel axis theorem says? Suppose this axis is x dash. So the moment of inertia about x dash will be given as ICM plus the mass of the body plus mass of the body into the distance between the two parallel axes, right? It's square basically. Okay, now we are just supposed to use this theorem and we'll have our answer, right? First of all, you are supposed to know that the moment of inertia about this axis, okay, passing through the diameter of a ring is given as mr square by 2. Remember the small things. Okay, the moment of inertia for a ring passing through the center of mass and perpendicular to the plane of the ring. Okay, so if you have a ring and the moment of the axis is like this, it's mr square. But if the axis is like this, the ring is rotating this way, then the moment of inertia is mr square by 2. Okay, now the next thing is the mass of the body times this distance, right? This distance, if you see, is nothing but radius, right? So this is half plus 1, that will be 3 mr square by 2. But here they want the answer in form of your, this r is, I'm so sorry, this r is smaller, right? basically the radius of your ring. Okay, they want the answer in terms of the length of the wire, and they want the answer in terms of the linear mass density. Okay, so mass, we can write it as, so linear mass density can be written as mass divided by length, right? For this wire, its mass, its total mass divided by its total length. So mass basically will be, right, rho into L. Okay, and L, if you see R is, we have already found out, just substitute this and we'll have our answer. Okay, so 3 m is rho L and R square, so square that, L square divided by 4 pi square. Okay, and here we also have a 2, right? So that will give us 3 rho L cube divided by 8 pi square, which is option D again. Okay, so option D is the correct choice over here. Just found the radius of the ring using the predefined logic, okay, and then use parallel axis theorem to find the moment of inertia about the x dash axis. Okay, let's move to the last question for the day, which is based on toppling. So question 15 and 16 over here. 16th one is your homework question. 15th one is based on toppling. That is also on toppling. So same principle, and that is your homework. Okay. So question 15, we have an equilateral triangle, maybe in the form of a prism. Okay. The coefficient of friction between this prism and ground is mu. Here you are going to apply a force F at this tip over here. You are supposed to tell what is the minimum force that should be applied in order for this object to topple. Okay, we want it to topple this way. Okay, we don't want it to slide. Okay, so since we apply force over here, it is going to topple. Okay, so that is what we want. Okay, now this might sound a bit subtle. It includes the shifting of your normal reaction. Okay, let's imagine it. Okay, when we push this object is going to tilt this way, right? It is going to tilt this way, and after some time, okay, the only point of contact that you'll see is this one, right? Like this, the only point of contact after some time will be this one, right? So the thing is that the normal reaction will pass from the extreme right. So that is the idea that was supposed to be caught over here. Okay, so instead of drawing it this way, I can simply draw it as the normal reaction is at the extreme right. Okay, the frictional force will oppose the motion. Okay, it will be in the backward direction. I can say mu n, the frictional force. Weight will be acting at the center of mass, mg, in the downward direction, and we also have this force F. Okay, now we just have to balance these forces. Okay, we have to balance the torque. Okay, so we can balance the torque about this point, basically at that point, because the normal reaction and mu n will not contribute to any torque about that point. They are basically unknown, right? We don't want those unknowns. Okay, and m and mu n. Okay, so we don't want those, we want to avoid those. So we'll find the torque about an axis which is passing through this point. Okay, so basically torque due to this force about this point. Okay, torque due to this force F about this point. Okay, so you just have to consider the perpendicular distance, this height over here. The height of this triangle is given as a root 3, right? This angle is 60, so this will be a sine 60. A sine 60 is root 3a by 2, sorry. So that will be root 3a by 2. Okay, so this distance is root 3a by 2, right? So you just have to write torque due to this force will be balanced by torque due to mg. This the torque due to normal force and mu n, since the axis is passing through that point, we will not consider those torque, right? Those are zero. Axis is passing through that point, right? So here, if you see the force, the torque due to force, which is toppling, is balanced by the torque by mg. Okay, so that is the condition for your minimum force of topple. Okay, this condition will give you the minimum force of topple. Actually, this force actually should be a little bit greater than your mg for it to topple, but anyways, ideally it can be equal. Okay, so this force, the torque due to this force is F cross R, right? They are perpendicular, so sine theta is 1. So F into R is root 3a by 2. Fine. And here torque due to mg if you see is in the downward direction, mg, right? And the point is over here, right? The perpendicular distance basically is a by 2, right? This distance here is a by 2, right? 60 cos, yeah, cos 60, a cos 60 is a by 2. So this distance from that point is a by 2, right? So the perpendicular distance is a by 2, force is mg times a by 2. Okay, so a and a will get cancelled. Here we are supposed to find that F minimum. Okay, so that will be given as 2 and 2 will also get cancelled, root 3 mg, or mg by root 3, sorry, mg by root 3, right? So option A, mg by root 3 is the correct choice over here. Okay, so I hope the approach was simple. You are just supposed to imagine this. Normal force is at the extreme right. You consider that point, find the torque about that point. This force, the torque due to that force equal to the torque due to the your weight. Okay, equate those torque, find the F, the minimum force, and that will be the minimum force. Okay, so you can repeat the process for this one and do tell me the answers in the comment section of this video, and if you answer it correctly you will receive a heart from me. Okay, so that is all for today's video. I hope you enjoyed it. If you did, smash that like button and also consider subscribing. I'll see you soon in the next video. Till then, keep enjoying physics.